Hi, hello everyone. So what we're going on to today is something pretty nifty, pretty cool. At least I think it is anyway. It's kind of a marriage between coordinate geometry and trigonometry. Yay! So if you remember trigonometry from your junior cert, trigonometry revolved around right angle triangles and other triangles, but more importantly, it revolved around three identities: sine, cos, and tan. Okay, remember sine was always opposite over the hypotenuse, and cos was always adjacent over the hypotenuse, and tan was always opposite over adjacent. Okay, now just to kind of reference this to make it a bit easier for you, if you look at it in terms of triangle, okay, and we take an angle of theta, that's a right angle, then opposite over adjacent, there's the opposite, and there's the hypotenuse, and there's the adjacent, ADJ. Okay, so that's the kind of basics of trigonometry from the junior cert. So how does this apply to the leaving cert? Well, the formula, if I want to, let's say I draw two lines, then the equation of the two lines can actually tell me about the angle that they make with each other. Okay, so if line 1 and line 2, they can tell you about the angle that they make with each other. Now you're saying, well, how did they do that? Well, listen, first of all, I'm going to show you the formula. I want you to get scared by it, and then I'm going to break down the formula and show you where it comes from, because I suppose once you know where something comes from, it loses all its fear, or it's meant to anyway. Okay, so here's the formula that we're going to be using. The tan of the angle, okay, that we're looking for between two lines is always going to be equal to plus or minus m1 minus m2 over 1 plus m1 by m2, where m1 and m2 are the slopes. Okay, so that's the generic formula for it. In reality, we tend to use tan of theta is equal to the absolute value of m1 minus m2 on 1 plus m1 times m2. Why do we use the absolute value? Because we tend to be looking for the acute angle, whereas the minus version will tend to give you the obtuse angle. Okay, so just be aware of that one. Okay, obtuse angle tend to be the bigger one. Okay, or lesser one, depending on whether it's bigger or less than 90 degrees. Okay, so we tend to use the absolute value but just be aware you can infer from one to the others by making it positive or negative. So where are these where is this all coming from? I hear you shout. Okay, well, let's kind of backtrack it and we'll have a look at a very simple example. Super simple. Again, just using very, very simple lines here just to kind of play around with things. Okay, so if you bear with me, we'll get through this pretty easily. Okay, so let's assume that this is L1. Sorry, this is L1 and this is L2. And we want to find the angle in between them. We're going to call this angle theta. Okay, so how are we going to do it? I hear you shout. Okay, so the trick to working this out revolves around the nature of slope. The very first thing you learned about slope was rise over run. If you remember that, so I'll just write it over here. Slope was equal to rise over run. Now, the beauty of rise over run in terms of slope is there is a trigonometrical identity that does look at rise over run. Now, if you have a look up at our little identities here, which of them do you think is the rise over run identity? Yeah, you're right. It's the tan. Look how tan is made. It's opposite, which is the rise bit of the right angle triangle, over adjacent, which is the run bit of the triangle. So rise over run, when you're actually getting the tan of an angle, you're actually getting the slope at which the hypotenuse is. So there you learn something new every day. So that's what we're going to be using. We're going to be using the fact that we know something about the tan of the angle. to infer what the slope of the angle is. Okay, so that's the plan anyway. So let's see how this actually kind of comes into fruition in the real world. So I'm going to use a new sheet of paper here. Just cover that because I don't need it. So how does this all kind of build itself up? Okay, well, in order, now you don't, this is all for the logic of it. Okay, so imagine you had an angle out here, let's call it alpha. Okay, now what do we know about the angle out here compared, let's say, to these two angles? Well, we know from junior cert that the external angle is equal to the sum of the opposite two internal angles. In other words, alpha, the angle, whatever it is at alpha, is equal to beta plus theta. That's true. So that means that theta is actually equal to alpha minus beta. Whatever those two angles are, when I take them away, I get that angle there. Now you think to yourself, well, that's not going to help me, is it? Well, you never know. Let's say, for example, that the tan of this angle, look at it there now, tan is rise over run. So whatever L2 is, okay, L2, the slope of it, its slope, okay? So again, you know, what you're doing here is you're kind of looking at it and thinking, okay, L2 slope, so I call it M2, is going to be equal to, let me see, the tan of beta, isn't it? And let's look at L1. L1 slope let's see what it's going to be. L1 slope, we call it M1, is going to be equal to the tan of alpha. Rise over run. So we have now the slopes in terms of tan. Okay. However, we know that theta is equal to alpha minus beta. So that would also mean that the tan of theta is equal to the tan, this is an important bit, of alpha minus beta. Wouldn't that be true? If that's 50 degrees, 50 degrees would be equal to the tan of, you know, whatever, 80 minus 30. 80 minus 30, if that was the other two angles, if you get my meaning. Okay, so whatever number that is, it's equal to those two numbers. So the tan of whatever that number is equal to the tan of the difference of those two numbers. That's what we're saying here. So you're with me so far? Now, this is where it gets cool. This little fella here in your log tables, if you go to your log tables, actually has an identity of its own. It has its own little formula, that little bit, and it's this. Starting to look familiar? Should do, because what did we have to just said? Tan of alpha is M1. Tan of beta, M2, over 1 plus the product. So that is how you do it. Now, if you wanted to get, let's just get a bit technical here, okay? If you wanted to get this one up here, well, that's just going to be 180 minus theta, okay? That's just going to be 180 minus theta. And then you can work out that's the same as getting the negative version, 180 minus whatever that answer is. So that's getting your obtuse angle. So that's how you get the very basic ones, okay? Right, so let's give this a go then. Let's do a couple of examples. So pick two lines. Sorry. And let's say let's pick another one. And let's say with these two lines, we want to find the point at which they cross over. So listen, you don't have to sketch these out, but just to visually see where you're going to be looking for this. This is going to have a negative slope, so let's just put them going somewhere like that. So let's say that's line 1, and this one has a positive slope, so let's put him up line 2. Okay, so we're looking for this angle here. Okay, theta. Okay, so what do we know? We know that the tan of theta is m1 minus m2 over 1 plus m1 m2. Okay, not too crazy like that. There's a plus or minus there, but the reality is we will take the absolute value of this because we're looking for the acute angle. You take 1 minus this, or sorry, you take 180 minus this if you're looking for the obtuse angle. So just be a little bit aware of that one. Okay, so let's try and work it out. Again, these aren't too hard once you know how to find slopes. So in both these cases, the slopes are in the y is equal to mx plus c form. So if you look at that, it's y equal to mx plus c. So they're very easy to identify the slopes. Remember, if they're in any other form, you can identify it very quickly by minus the coefficient of x over the coefficient of y. That, you know, but you know that already. We've done that plenty of times. So in this case, we have slope 1. Okay, it doesn't make a difference which one is which, really, because we look for the absolute value of them. But let's say we go with the easier one. M1 is equal to 2, and M2 is equal to minus 3. Okay, so the tan of theta. So the tan of theta is going to be equal to, and we'll just go absolute values on this one just so we won't have any magic going on here. It'll be 2, and it's meant to be 2 minus 3, but that's going to be 2 minus 3 over 1 plus 2 by minus 3. Now use your friend Mr. Calculator if you're not too comfortable doing that, but that's tan of theta is going to be equal to 2 plus 3 is 5 over 1 minus 6, which is minus 5. So that's absolute value, which is minus 1. So tan of theta is 1. Okay, so tan of theta is 1, then theta is going to be tan inverse of 1. Tan inverse of 1, you can look it up on the log tables, which I would suggest you doing it, but it's 45 degrees. Now, if you wanted the obtuse angle, then it'd be 180 minus theta, which would be 180 minus 45, which would be 135 degrees, if we wanted to go down that route. Okay, so that's the acute, which is the one we want. That's the obtuse, which the viewer asked to find it. Okay, so that's a very simple one. Now, listen, that could come up in an exam. That's a nice, easy 5 marker, you know, happy days, and maybe do something then with the angle, you know, something weird like that. But, you know, there's no law against something like that coming up. You know, it's perfectly acceptable as a one to kind of come up. So I suppose what you're really asking me is like, sir, where's the, you know, Mr. Gary, where's the juice in this? Where's the kind of juicy bits? Okay, the juicy bits come when you have examples like so. Okay, so I'm going to use a very easy example for this because I don't want to scare you off at the very start of this, but literally this could be anything. So imagine 2 lines that are perpendicular to each other and they intersect. So let's just put it in the intersection. So I'm going to let the lines move on, but they intersect here at this point. Okay, and let's call that point, I don't know, 2, 3. Okay, just using an example from the books. It's easy enough to do. So this is a right angle triangle. Sorry, this is a right angle. Okay, now the question then becomes, how would we determine the equation of those 2 lines if we don't know anything about them apart from where they meet? Well, if you could possibly, and this is usually given to you, have a third line that connects them. And if we knew the angles involved, then we'd have equation of line gives you slope with angle with other line, and you could infer from it one of the slopes, and then obviously because you've got perpendicularity going on here, you can use your perpendicular rule to get the other slope, and you have a point in your y minus y1. So you see where we're going with this. It's a bit more involved, but listen, let's have a look at this one then. Okay, so let's put a line equation on this one. X minus 2y equal to 1. So that's this fella here. And we're again going to use the one from the previous one. Let's use 45 degrees, which would make that 45 degrees. So you can go either way on this. Okay, doesn't make a difference. So let's put some slopes on this. Well, we know what the slope of this one, so let's call that M1. The slope of that one is going to be minus the number in front of the X over the number in front of the Y, which is a half. Okay, so that's the slope of this one. So we've got his slope. Now, we need the other slope. So M2, we're just going to call it M2. We don't know what it is. But you can see where we're going with this because we have a lot of the information. We know the angle that they make between them. So we put them into our formula. Okay, so tan of 45 degrees is going to be equal to, now I'm going to use the plus and minus this time. And you said, why, sir? You didn't use it the last time, because we don't know if it's obtuse. I said, what I'm saying to you is we don't know which version we want to give you the acute one. So we're going to use the kind of generic one, M1. So it's going to be half minus M2 over 1 plus a half times M2. So you can see we've everything apart from the M2. So just really a matter of, figuring it out. Okay. Let's work it out. We know what the tan of 45 is. It's uno. Okay. So 1 is equal to, now, let's try and work this out a little bit better. 1 is going to be equal to, I have a half top and bottom, so I can multiply both sides by 2, can't I? Or I can multiply top and bottom here by 2 and not affect, it's the same thing. So I'm going to just do that. Plus or minus, 2 times a half is 1, minus 2m2 over 2 plus m2. Because a half times 2 is 1 and 1m2. Okay, so now I've got a bit more going for me here. Okay, so I'm going to keep the plus and minus with the top bit, so I'm just going to cross multiply by the bottom bit. So that's 1, that's the same thing. So that's 2 plus m2 is equal to plus or minus 1 minus 2m2. So you can see where we're going with this. So we have two possibilities here, don't we? We have a plus version and a minus version. So we put the plus version this side and the minus version this side. So plus version is going to be 2 plus m2 is equal to 1 minus 2m2. That's the plus version. And then we've got 2 plus m2 is equal to, and let's put the negative version. I'm going to do this in stages so no one gets kind of scared about this. Okay, and then we'll distribute the negative across both signs, or both parts of the bracket. So let's try and solve this one. That's 3m2 is equal to minus 1, m2 is equal to minus a third. And listen, you don't need to be a rocket scientist to figure out that the answer here is use our perpendicular rule. What's the other possibility? Well, it's going to be 3, isn't it? But let's show that it is 3. 2 plus m2 is equal to minus 1 plus 2m2. And what are we going to be left where? We're going to be left with an m2 on this side if I bring him there, and you're going to be left with a 3 on this side. Quelle surprise. Okay, so it is exactly what we thought it was going to be. So where do we go from here? Well, I hear you scream. Well, we have 2. Okay, we have 2 of them, and we have a common point. So let's do 2 versions of this. We've got m equal to minus a third and 2 and 3, and we've got m equal to 3, and we've got 2 and 3. x1, y1, x2, y2. So what have we got? Y minus y1 is equal to minus a third on x minus 2, and then y minus y1 is equal to 3 on x minus 2. We'll do this one first. It's easier. Y minus 3 is equal to 3x minus 2. 3x minus y plus 1. Is that one right? Let's do it again. Y minus 3 is equal to 3x minus 6. And I hear you screaming at me through the video. I don't always have a blind spot with that. Minus 6, so that's minus 3. Okay, 3x minus y minus 3 equals 0. And then on this side, distribute the 3 from the bottom across to this side. 3y minus 9 is equal to, distribute the minus 1 in, plus 2. Didn't get it wrong that time. Bring it all to the side. X plus 3y minus 11 equals 0. And there you have the two possible equations. Right. So there you go. Have fun with them.